Okay, this is our final lecture in this course, and we will talk about something which is, I believe, the most interesting part. How to control people. How to control software. We discussed how you can control software. You can use style checkers, you can use unit tests, you can use integration tests, you can use static analyzers, you can use continuous integration pipelines, you can do many things in order to control the quality in your repository, so that people do not bring the troubles into your code, and you don't bring the troubles, you don't make mistakes, you don't turn your code into mess. The question is, aside from all these methods, how we can ensure that there is some discipline and there is a nice atmosphere and a nice culture in our repository when people work with people, and they enjoy working. Not only they enjoy coding, but they enjoy contributing the code. They enjoy communicating with people in the project. So the rules are simple, and I will show you. It's just an informal discussion. I don't think I will show you a lot of code, but no code in this part. Just the principles of living together with other people in the project. A number of rules. Let's make this discussion unstructured. Just rules one by one. First one, I highly recommend you to, when you work in the team, try to keep your discussions, try to keep your discussions about technical things, about organization of the code, about architecture of your product, to keep all this in the tickets, or in GitHub they're called issues. Every time you want something to be discussed, every time you don't understand something in the repository, every time you don't like something in the repository, you don't like the way something is coded, you don't like some class, you don't understand what this class is for, you don't understand how this method works, you don't know the purpose of this piece of code. You want somebody to explain it to you. You don't go to people, you don't ask people directly. You create a ticket. You create a ticket, and in this ticket you say that something is wrong in the repository. I need a better repository. I need the repository to move to a better state. And then when you say it in the ticket, then somebody will jump in and either will answer your question, but that would be the worst case scenario, if they just answer your question and close the ticket. But in the best scenario, if the team is doing the right work and they understand what they're doing, they will listen to your concern. They will understand that something is wrong with the repository. If this person is asking what's going on, is asking for help, is asking for an explanation, it means that the code base is not perfect. It means that the README file is not perfect. And then they will fix that and ask you in the ticket, what do you think now? We don't explain to you anything. We just listen to your concern. We listen to you are lost. And then we say, hold on. We're not going to tell you, for example, I can compare it with, let's say the person is lost on the street. And the person is coming to a policeman and says, where is the train station? The policeman will say, it's there, you go this direction. But a good policeman will do it, of course, but then the policeman will see, okay, why the person got lost? Because there are no signs where where is the train station. And the policeman will go somewhere and will file a complaint about that, not a complaint, but a suggestion that we need to fix the street. We need to put this sign where it's visible. You do the same. When somebody comes to you with a question about your project, with a question about the repository, you don't just help that person and show where is the train station. You fix your territory, you fix your repository, so that tomorrow this question will not be asked. And if you're on the other side, if something is unclear for you, you don't go directly to the policeman. You don't go directly to the architect of the project in Telegram, for example, or by email and say, hey, dude, please help me directly. Just train me. I love your repository. Please give me this information. You don't do that. You create a ticket. And in the ticket, you explain your concern. Even if it's a team of 2 people working together, sitting next to each other in the room, you still follow the same principle. You don't ask for information, you complain about the lack of information in the repository. The repository is not going to train you. I usually say it's a very popular phrase in my world. It's not a school. We're not a school here. Our job is not to train you. Our job is not to, this is not what the money in the project must be spent for, to train programmers. Definitely not. Not to make you smart, not to make you knowledgeable enough about this repository. Definitely not. We want to improve the repository. We want to invest every minute of our life into making the code and documentation better. Every time you come in with a problem, it's an opportunity for us to improve the repository. So you must love those tickets when coming to you. When people complain about your stuff, when people don't like your repository, it's amazing because they did a free job for you. They tested it. They found the weak spot. They found the gap of the code, the documentation. Something is wrong. So great, say thank you very much and then improve it. That's the first fundamental principle. It's not a school, so don't ask for help, don't seek for help. Instead, complain about the lack of information. So even when you write the ticket, don't say, please explain me how to, say, your documentation is not explaining to me enough, is not telling me enough, and is not giving me enough information. I'm not asking to help. I'm saying there's a wrong. The README file is wrong. The README file is missing the information. That's the professional way of formulating the ticket. Instead of saying, could you please help me understand how to use your library? Because I just read your README file and I found how to use it on Ubuntu, on Linux, but I didn't find how to use it on Windows. That's a wrong way of formulating a question. The right way is saying, your README file doesn't have the information of how to use this library on Windows. Please fix. That's your bottom line. Please fix. They fix it. Not please teach me, not please help me, but please fix. So always, I can make a bottom line, always blame the repository. Blame the code, blame the repository. But don't blame the authors. Don't blame the creators of the repository. Don't say, you guys did a wrong job. I don't like how you designed this. No, say your file has a white spot, that has a piece of, has a piece of there's a white spot in your README file which you better fill with the information. So I'm not blaming you. I'm blaming your documentation. That's the first important principle. I would call it ticket principle. I wrote for myself a ticket principle. So I explained it to you. Everything should happen in the ticket. When you file a ticket with a problem, you expect the help in the code. When the code is improved, you close the ticket. Second is the pull request. So when people join my team, usually I tell them this basic principles that if you look at the code, I expect from you 2 things. One of 2 things. Thing number 1, I expect from you a ticket. If something is wrong in the repository, you don't understand anything, just like I explained to you, make a ticket. If you don't make a ticket, then make a pull request. If everything is clear for you, then make an improvement. You know what to do. There's a task for you. So it works like this. Let's say you join my team and I work with some code. You join my team as a new programmer and I tell you, this is the task for you. Just make a new feature. Make this code work, like introduce new feature. And then I expect from you tomorrow, not in a week, actually in a few hours, to come back to me with the result. And the result is one of 2 things. You either bring me back a ticket where you explain what's wrong, or you come back and you make a pull request. So either something is not clear for you, then it's a ticket, or everything is clear, you may change it. If you spend 2 days telling me I'm still trying to understand how things work, I'm still learning this code, then I know you're not doing anything, you're just lazy. Because you're not supposed to learn. If something is, if everything is absolutely clear, like it should be, a good designed repository or well-organized code must be easy to understand in a few minutes. You just open the code, open the class, you read it, you understand it, it's clear. You immediately know what to do, how to improve it. You need a few hours maximum, but not days. But if something is wrong, if the code is not as good as I just said, then I'm expecting you not to sit there and learn and trying to understand yourself what's going on, why this method is there, what this method is doing. But you need to immediately complain to the repository. Immediately file a ticket and say, this piece of code is lacking the Java doc block. Please add this Java doc block. Make it, give it to me because I need it. If you don't do that, and if you don't submit pull request, then just that's it. You're not worth the salary you're getting. That kind of harsh, but that's really the truth. So first is ticket, second is pull request. Now the question is how to organize those pull requests, because this pull request is the main channel of information from developers to the code repository. So rule number one, try to make pull requests short. I think it's very obvious. I think everybody understands this, but when I see how people work, especially people who just joined the team, my teams and the teams I know, they usually bring pull requests of 500 lines changed. And this is something which usually people cannot digest, the reviewers, and this leads to big troubles with the motivation, with the enthusiasm, with the energy of people, because you work a lot, you spend a lot of time to write that large pull request of 500 lines, and when you submit this pull request, it's extremely hard to review it. It's extremely hard to understand whether this code is actually worth something, or maybe you just code too much, and we just need to close the entire pull request. So my point is that try to make pull requests as short as possible, and not by the counting of lines of code, because this metric is not really effective in this case. I would not go for metrics in this situation. So we tried that. I tried that in my practice a number of times, telling people that we're not accepting pull requests if they're longer than 100 lines. But it doesn't work. It doesn't really work because sometimes you need 1,000 lines because you maybe just add a text file to the repository, or maybe you just make a massive change to all files and you change just one line, the same line in all files. And of course you can introduce 1,000 lines, 1,000 changed lines, but it doesn't mean that you're violating the principle that the pull request must be short. I think the principle must sound like the pull request must change as little as possible. As little as possible. If you can't change less than you're changing now, then your pull request is not good enough. So I don't need to say, maybe it is extremely obvious that you don't combine changes into one pull request. Changes which are irrelevant, which are not related to each other. So if you're, for example, changing the functionality of a front end, but at the same time you're doing something with the polishing another piece of code just because you find it dirty, so you decided to polish it. So you put these pieces together just because you're lazy enough to create a new branch. That's wrong. You should not do this. A pull request must only do as little as possible in this particular situation. The minimum amount of changes. You cannot go smaller than you submit that as a pull request. Small pull request is extremely important. And there are not many, but I've read studies about that, where people they studied the situation in software teams, and in order with an attempt to try to find out whether it's really true that small pull requests they're really more effective for, and how did they measure their effectiveness? How would you do that if you would try to measure that? Of course, by the time which it takes to merge the request. So the shorter the request, the faster it will be merged, and that's exactly the metric which can cover many things in the software team. So if pull requests get into the master branch, into the main branch, into the development trunk, if they get faster, then your discipline, your environment, your coding ecosystem is better, comparing to the situation when they stay longer, and they sometimes may turn into so-called stale pull requests. Stale means that they stay there and they get expired, and eventually they may even get deleted from the repository, because if they stay longer than just a few days, maybe a few hours, if the team is huge and the team is actively contributing, then it will be hard to merge them in the end, maybe impossible, because there will be merge conflicts, and the amount of those merge conflicts will just grow, and eventually the author of the pull request will just lose the interest, lose the motivation, lose everything, and they will just abandon their pull request and delete it. And that means waste of time. That means waste of money. So the company is paying you to make changes. You try to do it, you make those changes, you submit the pull request. It's huge. Nobody wants to accept it because it changes too many things. It's hard to understand whether these things really need to be changed. We cannot trust you just blindly because we don't do that. We just need to be sure that these changes are really important and really need to get there. So we keep it on file, we keep discussing it, we keep reviewing it, and it gets longer and longer. At the same time, smaller pull requests get in, they get into the same files which you changed. Eventually, your huge pull request, we can just throw it away. Which means what? Which means we paid you for something which will never get delivered from you. It means you wasted our money and our time because we spent time on the reviewing your stuff. So small pull request, focused pull request is the rule of high importance. Then let's discuss how you format, how you present your pull requests. Of course, again, maybe it's super obvious, but people don't do that. Explain the changes you make. It's not enough just to send a pull request and just expect us to understand what you're doing just from the code you submitted. In the description of the pull request, write a few lines explaining why you're doing these changes and what these changes are about. So say it in English. And of course, make a proper title of the pull request. Again, it's super obvious, but people don't do that. I get pull requests every day which are titled like changes or fixed or whatever, like you see, fix. That's the very typical title for a pull request, just a fix. And then figure it out what I'm doing. It's my job now to understand what's going on. I don't want it to be my job. I want to read the description of the pull request, understand what's going on, and then it will help me to accept your changes. So describe as much as possible before you submit it. And now we're getting to the next point, which is also important. Remember that when you submit a pull request or when you make a ticket in the repository, it's always your responsibility to push things through. Nobody needs your pull. Let's make it extreme. Let's take it an extreme. Let's assume an extreme attitude. Nobody wants your pull request. Nobody cares about your problems. Nobody cares about your tickets. We are busy doing something else. We're developing the software here. And now there's coming an issue from you. And in the issue you say, this piece of information in the documentation is missing, like we just discussed. Or you're submitting a pull request and saying, hey, there's the changes which I just wrote, and I believe these changes, they belong to the repository, please accept it. You do it. But then it's your job to make sure the answer will come. It's your job to push it through, to remember us, to remind us about this pull request. If nobody's answering you, don't get offended. It's not because of you. It's not because we don't pay attention. We just don't pay attention to anything because we do our own stuff. We're focused on our responsibilities. So if you don't, for example, let's say I am a developer. It happens to me every second day. I have a repository, let's say on GitHub, and there are people submitting the pull request to me. The pull request submitted, I'm receiving, telling you, every day I'm reviewing maybe, 20 pull requests, something like this. 20 pull requests from people. And then another 40 pull requests from robots. So this is approximately the amount of work every day. And then your pull request is somewhere there. With a high probability, I will just miss it and just delete the information about this pull request, and that's it. You don't get offended. You don't stay quiet for more than a few days. You remind me again. You go to the pull request and say, hey, don't forget about my pull request. It's extremely important. Please pay attention. It's okay to act like this, I believe. Of course, you do it in a polite way. You don't post just the same message all over and over again, but you try to find the way to get your stuff through. So have this mindset in your head that pull requests and issues, they're all your responsibility until they get into the repository, until they get merged, until they get solved. They're all your job to push them through. It's not like they're gonna pull it from you, even though they're called pull requests, but it's your business to push this stuff to us. Many people don't understand it. They get offended. They stay quiet. They wait for something, and then we see that there's just 2 weeks no answer. Then they come and say, "Hey, but you didn't see my pull request for 2 weeks, and now it's too old. Now there are too many merge conflicts. It's your fault." We say, "No, it's your fault. You didn't remind us. You were not aggressive enough. I mean, we don't care. You were aggressive enough. You didn't. It doesn't matter. It's just your fault. It's just if the pull request is not merged, it is your fault. That's it. Nobody's else. Not the reviewers, not our CI, nothing. It's just your fault." Which leads us to the second point, which is also interesting to mention, is that I believe in a good team there has to be a mindset, there has to be a principle in the team that a programmer is responsible for the code only before the code is merged. When the code is merged, when the code is already in the repository, we absolutely never blame the author of the code, which is not what many people will tell you actually in the industry. Because people, if you listen to other authors, other developers, many of them will tell you that no, we need to be responsible for our code. There's a code ownership, even the concept that if it's your code in the repository, and then because of your code we lost money, for example, there's credit cards were stolen, or some security bug was found because of your code, then we're gonna find you and we're gonna blame you for that. I think it's a wrong concept completely. I think that we need to blame programmer before we click the merge button. That's the moment when we blame. We completely blame. We don't merge. We say, no, we don't like your code. Fix it here, fix it there. Make it perfect until we like it. And we are completely against the author of the pull request at this point. We're like enemies. We're like opponents, not enemies, opponents. So you are the author of the pull request. I am the acceptor of the pull request. So you need to fight with me until I'm convinced that your code is good enough. Then I click the button. That's it. It's not your code anymore. It's our code. It's my code. If it's my repository, it's my code. And after that, I only blame myself, not you, because I completely lose the information about who gave me the code. I don't pay attention. Of course, I know that I have this information, but I absolutely pay zero attention to that knowledge. That's how it should be. I would call it blame-free environment. It has to be completely blame-free. So we don't blame people for their code. We blame them only until we merge it. Try it out, because in many teams it's not the case. Another idea which I want to share is that when you it's a bit more technical. So when you make your commits, when you make your messages, when you text in the issues, when you again make commits, when you describe your commits, try to be, of course, like in the documentation, try to be as descriptive as possible, but at the same time as short as possible. But also use the syntax highlight, not the syntax highlighting, but cross-referencing instruments of GitHub or whatever tool you use. It means that always have a ticket which you work on. If you fix a bug, if you introduce a new feature, even if it's your personal project, make it a rule for you. Even this project of one person, always start coding when you have a ticket with a number. So you don't just code into the master branch just because the day started. You have a number in the number of the ticket. That's make it a rule. When you have a number, then each commit which you make, you in the commit message you mention this number. You mention that you're coding for this. You're making the changes for this ticket number. When you make a pull request, you also connect your pull request in the text to this ticket number. So everything, if I look in your repository later, everything should be, all the changes should be connected to specific ticket numbers. There should be no change which is not motivated. So this ticket is a motivation for your changes. So imagine that each ticket has money attached to it. When you code without a ticket, it's like you're coding for no money. So keep it like this in your head. The ticket is like somebody needs your changes. There always has to be like that in the repository. You always has to work for somebody, even if it's you who created this ticket before. But you work for somebody who needs your work. In a company, when you will join a company, or you work in the company right now, the tickets will be created to you by the business usually, or by your manager, or by your fellow programmers who's sitting next to you. But it's always going to be somebody who you deliver your result to. And when you complete the result in the ticket you say, hey, Jeffrey, please look at the results. Please close my ticket. So for you, your main job when you code is to close tickets. Not to freely code with no end because you love coding, but to close tickets. I'm doing it in my repositories always, even in the repositories where I'm myself, just alone. I always kind of try to imagine, like I said, imagine there is money attached to the ticket. The money means somebody paid for it. It means somebody needs that. And when you finish, you close, and that's your result. Even in good teams, I believe, in good teams, the result of people, the productivity of programmers is tracked by the number of tickets they close. That's the metric number one, I believe. The more tickets you close, the better you are. The less tickets I close, the worse programmer I am. That's it. In a good team, people try to create tickets which are of more or less the same size, which is as small as possible. Of course, try to work on tickets which are as small as possible. If the ticket is big, then decompose it into smaller tickets. If the ticket is huge, like implement the new functionality, then of course break it down into 10 smaller tickets and then work on these 10 steps. Each step should end with a success results, which is delivered to somebody, maybe to yourself, maybe to your friend, but delivered. This will create in your head the understanding that you are working towards a set of goals, a set of milestones. So each closed ticket is a milestone which you achieve, which you reach, which you it's like a line which you cross. The more tickets, the better, obviously. So if I open the repository and I see there's a 500 commits and there are 2 tickets and two pull requests, I know what's going on. There are people who are not disciplined, who are not structured. Their work is not structured. They are not. They cannot not control, but they cannot. They cannot discipline themselves. I will put it this way. So tickets are extremely important, and not only having tickets, but linking them to pull requests and backward. So I have to be able to always, that's called traceability. I think we discussed that some time ago, traceability. So the code must have so-called traceability. It means that I can jump into a line of code, any line of code, and I should always be able to trace it back to the original motivation, why this line of code is here. Actually, in really important and serious projects where human life is at stake. For example, you work in medicine, or you work in military, where it's you cannot just write code for fun. You need to have this traceability. So if you ever get into the project like this, then if it's organized properly, then this information must be extremely important. Because if somebody dies because of the code there, then we will try to find out what happened. Either it was a mistake, an honest mistake, or somebody put the line in the code on purpose. So the investigation will start like this. Why did this happen? Because of these 3 lines in the code. Okay, let's find out who put these lines. Jeffrey. Why Jeffrey did it? Jeffrey did it because he did it in this pull request. Okay, let's open the pull request. Why he did the pull request? Because of the issue. Who created the issue? The issue was created by Mary. Okay, why Mary created this issue? Because there was another issue created by Peter. Okay, and so on and so on. So this traceability must go to the original intent of a customer. So we will get into the use case, which was submitted to us. And in the use case, it was said, please let the button, when it's clicked, kill the patient. I don't know, I'm kidding. But do something. So we'll know why Jeffrey created these 3 lines. Because, and then we go up and up. And there is a traceability matrix, and there is software which maintain this relationship. It's a huge territory of in software engineering. It's called traceability, how to maintain this traceability. Of course, when you code in GitHub, you don't have this necessity to make everything so traceable, but you can. You can do it because GitHub gives you this feature out of the box. You don't need to use what people were using 20 years ago when they had these spreadsheets, the traceability matrix. They really had to document every line. It's all coming to us in GitHub out of the box. All you need to do is remember the principle. The principle, it's simple. You code only when it's asked by somebody in the ticket. And you always, when you code, you make sure that this code, this commit, is linked to the intent of imaginary customer. I don't know whether it rings some bells in your head, but try to remember that. It should help you. Another topic, which I also, another recommendation for keeping the ecosystem right is, again, maybe a very obvious thing, but I still need to say it. Be polite. Be polite in the way you communicate with the people who you review and the people who review your code. Because there were many research studies about how much this relationship in the office affect the code we create. And the studies, they found, many of them, that when people sit next to each other in the office, they have some relationship. And people who have good relationship, they are really bad in code review. So if I'm your friend and you're my friend, then the code which we will together produce after reviewing each other will be really bad. Worse, it will be worse if we absolutely don't know each other. If I don't know you, I don't care who you are, you don't care who I am, we never met in the office, we're just 2 strangers in GitHub, then the quality will be much higher quality. So it is a problem. It is a problem because we're people, we tend to get to know each other, we tend to like each other, we tend to become friends. And once we become friends, then the code suffers, the quality suffers. So how to solve that? How to review a pull request from a friend and not lose a friend, and not to lose the quality of the review, because we need to be harsh sometimes, technically. Sometimes we need to reject, sometimes we need to refuse the changes, sometimes we need to ask somebody to rewrite everything. That's painful. You know how it is if you are a programmer. So what to do? I would suggest first to always try to be when you express, that's how I do it. When I get the code on review and I see that the code is that something is wrong, something I don't like, I'm trying not to say I don't like it. I'm trying to say it is not a good practice to do that, and then prove it with the link, with the reference, with the link to Stack Overflow, maybe to the book. So try to say that it's not my opinion, that it is a common opinion, that it is a rule defined somewhere, and then find the link to this rule. I have many blog posts on my blog which were written exactly for that. So I was reviewing the code, and then I see that people keep making the same mistake. And I wanted to tell them, look, this is a mistake. I don't like you to write it this way. And I always had to show them the same links, the same explanation. So I wrote a blog post. For example, I personally don't like when people use null references, when they return null or when they accept null in their methods and their functions. So I was saying them, it's wrong because people wrote the papers about that, looked here, looked there. But then I got tired of doing that. So I wrote a blog post. In the blog post, I said why null is a bad idea. Like a detailed blog post, like a 3 pages blog post. Now, when somebody submits the code to me, I say, oh, you use null. Please read this blog post. There are so many people saying it's wrong. Don't use it. Not my opinion, just my blog post, which is not really my opinion, it's just a summary of opinions which I collected from somewhere. So always try, not always, but try to do the same. Try to not stay in front of the code writer saying that you're not going to go through because I personally don't like what you wrote. But find a reason why the code is imperfect. That's probably recommendation, the main recommendation number 1, which I can give. Focus on remove yourself. Let's put it this way: try to remove your personality from the discussion. That will help you to save the friendship, a good relationship, and will try to be more or less objective. Sometimes it's not possible because there are multiple opinions on the market about, for example, null pointers. There are many opinions which say that it's okay to use null pointers. In this case, my second recommendation is when you find a situation like this, when you find that you are saying something in the code review and the people argue back and they say something wrong, it means that now it's time for you, maybe you together, everybody who work in the project, to sit together and decide which principles your project listens to. You need to decide whether null pointers are okay or not okay in your repository and put it into README. So create the list of technical rules, technical principles in your code, which everybody will listen to and everybody will obey. It's like with the style checking. So imagine, I can't even imagine how hard it would be to accept, to do the code review if our projects would not have automated style checkers. It would be a disaster because any programmer would write the code they want and they would submit those pull requests. And I would look at them and everything would be wrong, in my opinion wrong, but in their opinion right. And I would ask them about every second line, rewrite it. And they would complain. They would say, why are you so picky? Why are you bothering me with this small micro cosmetic changes? So in order to prevent that, we just say, hey, we're not going to discuss that. We just agree that we're going to use check style. Check style is a Java style checker. And that's it. It's like a judge for us. It's not my opinion anymore. It's not your opinion anymore. We have a tool for that, and that tool makes the decisions. We don't argue with the tool. We just listen to the tool. So try as much as possible to move the opinions about architecture, design, to some other place, to the third place from your head, from the discussion. And then everybody will just read that and they will agree or disagree, but these are the principles in our particular project. When you move to another project, you will have different principles. That's what I say to people sometimes who work with me. Some of them disagree with our principles. And I say, I also disagree with some of the principles, but we just decided, we just agreed, you know how they say, agree to disagree. So we agreed that some of us may disagree with some of the principles. But for the life cycle of the project, we agreed that we're gonna obey the principles, just for this life cycle. When we move to another project, there'll be different principles, where we're gonna be writing code differently. So by being polite, I mean not saying thank you multiple times or saying please. Please is not going to help you in the code review. No matter how many times you say please, if I don't like your code, I don't like your code. You're only making it worse if you're trying to convince me using the word please, or me trying to say sorry, excuse me when I don't like your code. I'm not really sorry. I don't want to pretend to be sorry. I need to be objective in order to not really offend you. Because if I'm giving my really personal opinion, which doesn't have any foundation, which doesn't have any proof outside of our conversation, then it's really offensive. It does look personal, because why? Your opinion is more important than mine. Let's say you're the reviewer and this is my code, so I send you my code and you say, please don't use, I don't know, please don't use global variables. But I like them, but you don't like them, and you don't prove that they're not good. So I feel like you're just making it personal, no matter how many times you say I'm sorry. So being polite again means that always trying to remove yourself from the picture, remove your personality, your personal opinion. It's hard, it's difficult. I mean, I spent many years on writing those blog posts, collecting the information in order to prove my point every time. Maybe you can do the same. Maybe you can, if you have certain beliefs about how the code should be written, then maybe you can also start writing some short blog posts. If you see that you are saying the same thing over and over again in the code review, then start making the knowledge base, your personal knowledge base, where you put together the information that is valuable for your code reviews. It's also interesting to discuss when we talk about discipline of coding. Maybe we can discuss whether let's say you are in a project and there are other people working with you. So how do we, having a team of programmers, how can we make sure that the best programmers who really care about quality and who we see that they're good programmers, they care, and we have also programmers who don't care about quality, and we also see them, we know who they are. So how do we, without being and sometimes it's impossible to get rid of people who don't care about quality, and sometimes it's we just need to work with them. And this is a situation which I've seen many times. People come to me telling these stories, complaining that I am a member of a team and I have 10 other programmers and I'm the only one, or maybe me and a few other people, who really care about how we code, but there are 8 people out of 10 who don't. They just put whatever they want in the code as long as it works, and that's it. So how to survive in this situation? How to not lose the motivation? How to not lose the the spirit of the team spirit? Maybe it's already lost, but the spirit for the work. If you see that you write the code and then you open the same file in a few days and it's again completely messed up, so you clean it up again and you push it, and in a few weeks it's again completely messed up because somebody put some wrong stuff in there which you don't like, which you don't feel like a good code. So what to do with that? How to survive? I think it's my best recommendation for that would be to isolate somehow the code you own from the code other people change. So if it's a large repository, find some block in there extract it somehow and say it's mine, so I will be responsible for it and I will maintain it. So somehow try to isolate yourself from other programmers, which is the worst solution, definitely. It's a solution which is, of course, you don't help the project in this case, because you only take care of the small piece. What about the other piece of the repository? It will be in a bad shape, right? Because nobody will care about it. So it's the worst scenario, definitely. You do that, but it's not really in favor of a project or a team. A better way would be to slowly start teaching people, and making some seminars, making some workshops in the team, trying to slowly, step by step, convince people that certain rules are important, and like I said before, put those rules into some common knowledge base of the team. Let's say you don't like people to use, let's say, null references, like I don't like it. So how do? You cannot just jump and say to all the 10 people, don't use these null references tomorrow just because I say so. They're not going to listen for that, unless you are a top manager. I mean, you are the boss, but still, even if you are the boss, they're not going to listen just like that. They will ask why, and the best case, and the worst case, they will still make them. They will still commit those changes when you don't see that. And you will catch that later, you will try to blame them, but they're going to be just laughing at you, and that's it. So the better way is to start discussing that, but slowly, not everything, not all the problems together. You don't tell people that you guys are writing bad code, because nobody's gonna like it. So you discuss step item by item. For example, null references. Let's sit together, discuss, agree about that they're not good, and then write it down. Put it into the list of principles, and better, not just the list of principles, but make an automated software somehow, automated code analyzer, which will prohibit the usage of certain code constructs. Some elements in the code. For example, null. For example, I don't know what else you don't like. Some maybe large classes. You say large classes is bad, so we don't make classes which have 50 methods. Less than 50 is okay, more than 50 is not okay. Pretty silly metric, but still. So we sit together and discuss, and some people will say, yeah, sometimes it's okay, but okay, they will agree. If you discuss, enough and enough, I mean, more and more, you will discuss longer and longer, then they will eventually agree. And that will go into the knowledge base, like we agree, no more than 50 methods. And then you put it into automated tool, and the automated tool will start automatically rejecting the code. And then people will start adapting to the tool. Then you make the next step. Again, you introduce the new rule, again, next rule. Again, you sit together, discuss, and you put this rule into some automated checker. And so on, step by step and step by step. In a year, you will see how people will start liking that. They will start liking the code, liking the rules, and you change the situation eventually. It's not going to happen fast. So code quality is something which costs time, first of all. Not even money, but time. It is time consuming, and if you're not prepared to spend a year to train your team, to improve your team, then you better not start. If the team is big enough. Of course, if there are 2 people, then maybe you can do it faster. But in a bigger team, it's. But if you do it, then you have a good chance to end up in a very good position, which will be in your favor, because you will be the leader of the quality control. Everybody will know that you are the driver of the good quality here, that you are the one who cares about quality. And they will eventually, when there will be a decision to make who is the architect or who is the next candidate for technical lead, for example, then they will pick you, because everybody knows that you were the driver, the pusher, the main motivator for increasing the quality. So start doing it. Don't isolate it. Don't blame the team just because they write bad quality. We all write bad quality, and it's always a matter of it is subjective. So if I look at my code, which I wrote 5 years ago, it's bad in my opinion. But 5 years ago, I didn't think so. I thought I was writing the great code. The same will happen to me in a few years when I look at the code I write now. The same happens to you. So if you look at the code you write now, you think it's great, and your friend writes bad code, or your colleague who works to you next table. But in a few years, you will change your opinion. So don't blame people. Blame always the system. Blame the repository, which is not strong enough to reject the bad code. Probably it's the most important message of the entire course, that we shouldn't blame people for the bad code. We blame the system, which is not strong enough to reject automatically the mistakes people make. And if the system gets stronger, and this is your job as an architect, as a quality, as a person who cares about quality, is to make the system stronger. Make the system as strong as possible to prevent it from degrading. And the system will always degrade. The system will go down if you don't invest into the system, if you don't make it stronger and stronger and stronger. So that's probably all I wanted to tell you in this in our course. You use tools to make quality higher. Tools. It's not about our desire, it's not about our passion, it's not about our willingness, it's not about the love to the coding or whatever. If I remove all the instruments which now control the quality in my projects, my personal projects, where I'm the only developer, in a few months, it will be a mess in the repository. It will be a mess. Even though I love, clean code, I love the code of high quality. The only thing which protects me from myself is the tools. The more tools I have, the more safer, the more comfort I feel while I code. So your job is, if you want to ensure quality in a software project, your job is to find more tools which will catch you when you make a mistake. The robots, the tools, the instruments, analyzers, checkers, they all must be sitting around you and watching you, how you code. The moment you make a mistake, they prevent it. They do not allow you to do that. How many tools you find depends on your enthusiasm, depends on your professional level. How many tools you can implement depends on your political skills. Like I told you, in the team, it's not going to be easy to just put the tool and say we all use it. You need to train people. You need to give them knowledge. You need to do the seminars, workshops, show them papers, videos, articles. Teach them and teach them. They eventually will agree to use that tool and that tool and that tool. Eventually, everybody will win.